Okay, for these integral questions, they're pretty straightforward. We'll take a look at them just to see how to go about doing them. These were quite simple, I thought. So most people got this one first. If you integrate this, you should get x cubed divided by 3 minus x to the 4 divided by 4 plus 2x plus c. That was a very basic one that you had to do for the first one. All right. For the second one, let's move it over here. What you should have noticed is there's a couple different ways of handling this one. First of all, if you wanted to, you can separate these so that they are on a separate denominator. That's one way you can handle this. Another way is you could put 1 plus x here, and you can bring this x to the 1/2. So normally we already know that the square root of x is equal to x to the 1/2. So we can bring that up here. So we have x to the minus 1/2. And then from here, what we can do is we can distribute the x inside these brackets like so. So if we do that, put these down here for now. If we do that, and I bring my integral back up here, I have integral of, well, x to the negative 1/2 times 1 is x to the negative 1/2. And x to the negative 1/2 times x, it should be, well, you add indices. So if this is x to the power of 1, you should have x to the 1/2. And this is dx, of course. So all I've done is distribute. I haven't even integrated yet. And now we can do the integration. So integrated this, you add 1 and divide by the same amount. Plus, you add 1, so that's 3/2, and divide by the same amount. And of course, you can simplify this a little bit. So x 2 to the x 1/2 plus, switch these around, 2x to the 3/2 over 3, and of course, plus your c at the very end. So that was question number 2 here, okay? Question number 3, if we look at it. Just move some of this stuff over here. Okay, for this one here, the easiest thing to realize is that you have this 1/2, and you can actually take that outside of the integral. And what's left is 1/x inside this integral. And there's a very easy integral. If you ever integrate 1 over the block to the power of 1, it is a ln. I told people this, and I still saw people try to put this x to the minus 1 up top here, and then integrate x to the minus 1 dx. And I even warned you, I said, if you add 1 to this, you get a 0. So I don't know what's going on with people in the class. Me warning people about this, and they still end up doing it on tests. People. This next one, I would have taken the 9 out front again, because you're allowed to take a constant out front. And then from here, the integral of e to the x is e to the x, so you end up getting 9e to the x plus your c. Of course, you should have a plus c on this one as well. If we take a look at the next two, I'll bring it down here, bring it down here. Okay. So the next one here is fairly straightforward. Again, if you integrate cos x, you should get sine x. So integral, if you just integrate 3 cos x, well, it's just 3 sine x. That's it. And if you integrate a sine x, you get a negative cos x. So this is negative 4 cos x. That was it. Done. The next one, you had to know a little bit about the unit circle. So you guys, unit circle, if you don't know it, figure it out. You've got a couple months left. if I integrate sine x, that one's easy. It's on the sheet. You should write cos x, put your plus c here. There's no sense in putting plus c because you have limits. So don't put plus c when you have limits. Never. It's pointless. And then you have pi, and then you have 2 pi. And now what you need to do is put minus cos of the upper limit in here. Subtract minus cos with the lower limit in here. That's what you have to do. And cos of 2 pi is 1, so you have a negative 1 here. And cos of pi is negative 1, but then you have a subtraction sign, so negative makes this positive. But then you have a negative kicking in here, so it makes another negative. So in the end, your answer is negative 2. That's what you have for this. Unit circle and making sure you don't mess up your signs. That's what this question was about. Okay. Finally, we have the last one. They love putting square roots and stuff because they know it freaks you guys out. So let's take a look at it. Easiest thing for you again to do is take the 10 out the front, and then you have 1 over, and I'll change this into indice form, 1 minus 5x. Most of the time we've been bringing stuff up because it's easier. So we have 10 times integral of 1 minus 5x to the minus 1/2 dx. Now this is one straight out of the book. If you integrate this, take the 10 out. I'll just put this in here for now, just in case. This, what you should do is you should add 1 to this negative 1/2, so it becomes positive 1/2, but then you have to divide out that amount as well. And then here you have a negative 5x, and if you looked at your rules, if there's a if you have ax plus b inside this bracket to the power of n, then you always, when you integrate this, there's a rule. It means you have to divide out by the a. In this case, we have a negative 5. So this is going to be actually in the bottom like so. So you have to remember that. So it's the anti-chain rule. 10 divided by negative 5 is negative 2. 1 minus 5x to the 1/2. Also divided by 1/2. So if you divide negative 2 by 1/2, you'll get negative 4. So your final answer is negative 4. 1 minus 5x to the positive 1/2, pardon me. So there you have that question. So that was page 1. So let's take a look at page 2 here. These one were a little bit more advanced, I suppose, if you want to call them that. So you had to integrate these 3 pieces of this integral, which I thought were straightforward. Integral of e to the x is e to the x. Integral of sine x is, I believe, minus cos x. And the integral of 1 is x. You have this. And then your step should be showing this first of all, and then putting this in this. If you don't do this, you will lose method marks. And now all I'm going to do is put in this pi and this 0. Now people were asking, what the heck is this exact value? Exact value means a non-rounded value. So if you put e to the pi in here minus cosine pi plus pi, these are all non-rounded values. So this is how you find the exact value in a question. They're going to ask you this on paper 1. And of course we have to subtract that with putting the lower limit in. So you have e to the 0 minus cos to the 0 plus 0. And now you have to just watch your signs. And you have to know unit circle. Cos pi is negative 1. So you'll have a negative. So you're going to have e to the pi plus 1 plus pi. Subtract, open brackets, e to the 0 is 1. Cos to the 0 is 1, so you have subtract 1, and then you have this 0. So in the end, this goes away completely, and this is your final answer here. Exact answer. You leave it in this form. It's a paper question. For this paper, the second question, you should write in your notation, if you know that it's f prime of x, you should go f of x, meaning the function is found by taking the integral. So this is proper notation, dx. So set up your integral with proper form, everything, or else you'll lose marks. And now integral of x squared is x cubed divided by 3. The integral of cos x is sine x, so 4 minus minus sine x. So we have sine x. And then this here is your f of x. And you have your plus c. And of course, they give you these things here so that you can find your c. We learned this. So you should make this equal to your f of x is your 3 equals to 0 cubed over 3 minus 4 sine of 0 plus c. Unit circle again. This here, sine of 0 is 0. People think it's 1. I don't know why. If you do the unit circle and you ask yourself, at 0 degrees, this is always the angle. At 0 degrees, what is the sine value? What is the y coordinate? Well, here, the y coordinate on this line is 0. So at 0, pi, 2 pi, this sine is always going to be 0. So what you end up with is 3 is equal to 0. And of course, you should rewrite your function because that's going to expect what they're going to expect you to do. X cubed divided by 3 minus 4 sine x plus 3, and then you're done. That was a quiz. So keep studying.